YouTube. In this video, we're going to put all the pieces together when it comes to graphing rational functions. And so all of these steps that we went through in the last video here, essentially all of these right here, I'm going to try to do this freehand without having to have those right next to me. But we're going to go ahead and start with the steps we went through last time, which was, first of all, we checked for the symmetry of our graph, if it had any symmetry. And I notice here that when I look at this, all of my x's are being taken to the second power or even power. So I suspect that when we plug in our negative x here, which we're certainly going to do to check for symmetry, this is going to be very helpful, as a matter of fact. We're going to learn this. Oops, this is a minus 9. We get minus 9. It looks like we end up with a situation where on top we get 2 times x squared, and on bottom we still get a positive x squared minus 9. And so because this is the same as f of x, what we've just learned is this. It is even. It's an even function. Also, that it has y-axis symmetry. So what this is going to do is it's going to save us some time. We're only going to have to graph 1/2 of this entire graph. So we've checked our symmetry. The next thing we want to do is find our y and our x-intercepts here. I'm going to start with our y-intercept because there is only one. And as a matter of fact, let's do this. Let's make a table of values over here to help supplement our graph. When we find a y-intercept, what we're saying is we're plugging in 0 for x. So we say y-intercept here. Make my work concise. We say f of 0 would be equal to 2 times 0 squared over 0 squared minus 9, or in other words, 0 over negative 9, or in other words, 0. So it goes through 0, 0. I'm going to go ahead and put that on my graph right here, 0, 0. But that also tells me that, well, then I must have an x-intercept at 0 also. So we'd say x-intercept. Okay, so remembering from my last video here, we say the x-intercept occurs when we set y equal to 0. So we're going to set the whole function equal to 0. But the idea is that the only way a whole fraction equals 0 is if the top is equal to 0. So we're going to set 2x squared equal to 0 and solve this. I'm going to divide both sides by 2. And I want you to understand this. These are two factors, x equals 0 and x equals 0. So either x equals 0 or x equals 0, or I'm going to say that we get x equals 0 twice. Now we put this on our grid. But what I'm going to note here is this has a multiplicity of 2, which is even. And so what this means is when when our graph hits at 0 here, it's going to touch and turn around, but it's not going to cross at that point. So same rules we follow with polynomials. So now we have symmetry, y-intercept, and x-intercept. Let's go ahead and find now our asymptotes. So we say vertical asymptotes first. These are, pretty easy to find. We'd say our initial expression here, when we factored it, 2x squared over x plus 3x minus 3, which I should have factored first, but here we go. Finding the zeros of the denominator. If x plus 3 times x minus 3 equals 0, then either x plus 3 equals 0 or x minus 3 equals 0. And so we get two values here. We say x equals plus or minus 3, or where our vertical asymptotes are. So we're going to go put those on the graph right now. We're going to say at x equals positive 3. Let's do this. Let's do it in red, pink, whatever, magenta, fuchsia. Right here at x equals 3, and then we're going to go here and say x equals negative 3, right there. We'll label these. So now I know a lot about my graph. Let's find its horizontal asymptote next. So x-intercepts, y-intercepts, vertical asymptote, horizontal asymptote, we compare the degrees. And I notice that the degrees here are balanced. Okay, that is to say that the top is second degree and the bottom is second degree. So our leading coefficient on the top here is this 2. Leading coefficient on the bottom is 1. So we're going to get y equals 2 over 1, or y equals 2 is our horizontal asymptote. So I'm going to go put this on here as well. Not the x-axis, but at y equals 2. We want to label this y equals 2. So as far as graphing the rest of this is concerned, what we're going to do is we're going to go out to the left of each 0, to the left and right of each 0 by 1 unit, and 1 unit to the left and right of each vertical asymptote. So we get to now plug in, let's see, this is negative 3. We're going to plug in, I suppose we would do, let's do the positive side. Let's do 1, 2, so it's to the right of our 0 here, but to the left of our asymptote, and then 4. And the only reason I'm not going to actually plug in negative 1, negative 2, and 4 is because I know that because of symmetry, they'll have to be the same things. So let's go ahead and start with f of 1. So we say f of 1. Take your time when it comes to doing this stuff here, always. So we'll put in a 1 here and here. So we would get 2 times 1 squared on top is 2. So on our table over here, I'd say I get 2 over. And then over here, I get 1 squared minus 9 is negative 8. So it's okay to go with a fraction on this. If you want to, we could just say negative 1/4. And so we say 1 comma negative 1/4 is on our graph. That'd be about right here. And because of symmetry, I know that negative 1 comma negative 1/4 is also, or yeah, negative 1/4 is going to be on our graph here. Same things. So now we'll plug in 2. And I'm going to cheat here. I'm going to say 2, 2, and 2. On the top this time, we get 2 times 2 times 2 is 8. On the bottom, I get 4 minus 9 is negative 5. So I'm going to get negative 8/5. What I'm going to write here is negative 1.6. And so I'm okay with going with a decimal on this one here. Also negative 1.6 here. So when we go 2 to the right, we go down 1 and then a little more than 1.5 here, negative 1.6. And then because of symmetry, we have it on this side also. So I can already see the middle part of our graph kind of doing this right here. Now on the outsides, I would suppose that if we plugged in 4, we would get f of 4. It's all scratch paperwork here. We'd say 4 squared all over 4 squared minus 9. We would get 2 times 16, which is 32, over 16 minus 9. So 32 over 7. You know what? I want to write 32 over 7 because what I know I'm about to do is get a decimal because I'd rather graph this with a decimal. So let's turn our calculator on here. We say 32 divided by 7. Suppose we could figure this out. 32 divided by 7 would be about 4.57. So approximately 4.57. Now I'm going to put these on my grid here, on my graph. So we'd say going 4 to the right, 1, 2, 3, 4. We're going to go up 1, 2, 3, 4, about 4.5. And so because of symmetry, this would have to lie on this side over here also. We'd say that this is 32/7 as well. So now when I look at this, I can tell you that the middle part of our graph had to start really close to the asymptotes. I didn't really give that a lot of room, but it is really close to the asymptote there. And then the outsides of our graphs, we'd have to have a couple of branches up here. So I would say that in this particular case, I feel bad because our table on the other page says, on this here, it says plot at least one point between and beyond each x-intercept and vertical asymptote. I think it's appropriate to actually plug in 5 here just to see where it would be at 5. So if we plug in 5, just really quickly here, we get 2 times 5 squared all over 5 squared minus 9. So we get two 25s on top, and we get 25 minus 9 on bottom, which would be 16. So 50 sixteenths, 50 divided by 16 is 3.125. So we have 50 sixteenths is 3.125. And so when I go out 5, I'd be up 1, 2, 3, and then just a little bit more. And because of symmetry, we'd have it on this side as well. But we'd say starting really close to the asymptote and then increasing without bound on the left. And then we'd say, okay, decreasing on this right side here always and approaching the asymptote. Cheers.